So let's get started on differentiation by first principles. The reason why we do differentiation by first principles is because we want you to understand where the formula comes from. You're always going to be able to check your answer using your power rule. And often the matrics ask, well, if we can do it by the power rule, why are we learning about first principles? The thing is that it always gets asked. So your first question on calculus in any paper one is always going to be to find the derivative of a function using first principles. So we've got to be able to do that. Also, they penalize if we do things that we're not supposed to. So they can penalize us for incorrect notation or dropping our limit notation, etc., etc. And these are supposed to be 5 easy marks. Okay, so we've got to be able to do it by first principles, and thereafter we would always be using our power rule. Okay, so before we jump into first principles, let's just talk about this word, differentiation, okay? If I didn't know what it meant and Yolanda didn't know what it meant, what would you tell us? What does the word differentiation mean to you? What do you understand it to mean? What does the word differentiation mean to you? Why is it doing this? What does differentiation mean to you? You can put it in the chat if you're afraid to unmute. What does differentiation mean to you?
Let's
Any
go, my
ideas?
people. I know you guys are not that quiet. There we go.
There we go. Okay, so Siam Tanda. There we go, Neo. Difference between two terms or more. Okay, so if you guys have a look in the chat, okay, Neo has put a very nice answer. It says the gradient of a point on a curve. Okay, so the word differentiation means gradient. Okay, so when you are differentiating, it means you are finding the gradient at a particular point. Another word that you might see in your textbooks. Yolanda, can you just help Carla? She's unable to see the screen. Is you may see the word derivative. Okay, so according to our textbooks, this is what they say. All right, they tell us that differentiation is working out the gradient of a tangent. Okay, a tangent is a straight line, or working out the gradient of a function at any point. It is also the instantaneous rate of change, which you will understand more when we do application of calculus, or it could mean the derivative of f at any point. Okay, so the derivative of f. So all of these words mean the same thing. All right, it means that we are working out the gradient at a particular point. Okay, so differentiation means calculating the gradient at a particular point. So the definition of differentiation is the gradient at a particular point. And I mean a particular point on the function. Okay, so let's start off and talk about the gradient of a straight line. Okay, so if I come along now and I draw a straight line like that, don't know why it does these silly things, but okay, there we go. There is a straight line. As I'm walking from left to right, so as x is getting bigger, all right, would I be walking uphill or would I be walking downhill? If I started off down here and I wanted to end off up there, Would I be walking downhill or uphill? Be walking uphill. Quite right. Okay, so the gradient of this pink line is positive or negative? The gradient of this pink line is positive or negative? It's positive. Good. Okay, so when I am walking uphill from left to right, your gradient is going to be positive. So my symbol for gradient is a lowercase m. Gradient is positive. I'm walking uphill. Now, does the steepness of the line change? Where I started down at the bottom and where I ended at the top, does the line become steeper at a certain point, or is it all the same? Does the line become steeper? No, it doesn't. It's the same. Okay, so the gradient is the same if I'm down at the bottom. Over here where I'm highlighting this in purple, the gradient is the same as where if I end up here where I'm highlighting in blue. Okay, the line didn't get steeper. It didn't change. The gradient stayed the same no matter where I was on the line. Okay, so if I came along and I wanted to measure the gradient over here, or if I wanted to measure the gradient there, or at the end over here, the gradient is exactly the same because it's a straight line. Okay, so for all straight lines, your gradient is constant. But it's different on curves. So if I come along and I draw a parabola, now this parabola is going to look a little bit weird to you. They're supposed to be nice arches. So nice arched. Sorry, neither of those are particularly good. A nice arched shape. But what I'm going to do is I'm going to draw a parabola that is a bit more rounded. It's still a parabola, but it's a bit more rounded. Now imagine that I'm also walking from left to right. Now I'm going to draw myself over here. Okay. If I'm here and I'm going in that direction, all right, what am I doing? Am I walking uphill or downhill? Imagine I'm walking up this hill. Okay, so the purple line is a hill. I'm walking uphill, aren't I? Okay. Now, if I'm over here where the green dot is, now let's pretend that I've got over there. Is it still as steep over here at the pink dot? Is it as steep at the pink dot as it was at the purple one? No, it's starting to level out a little bit because what I'm doing is I'm approaching the top of the mountain, aren't I? Okay, so I'm not panting as much anymore. I'm starting to be able to breathe a little bit easier. What happens here? I've got to the top of the mountain. Am I going up? Am I going down? Okay. So at this point over here where my turning point is, I'm not going up or down. I've got to the top of the mountain. But if I now end up over here, let's say let's get a different color, you got purple. Now if I'm here at the purple point, I'm now walking in that direction. I'm now walking. Yeah, that's a stationary point. Quite right, Shisana. At your turning point is a stationary point. It's another word for it. Correct, stationary point. And now I'm starting to walk downhill again. All right, so the gradient of my curve changes depending where on the curve I am. So if I were to measure gradient here at the green point, it would be a different value to where it was at the pink point. It would still be positive. So gradient at the green point and gradient at the pink point would still both be positive, right? But they would be different values. Just like at these two purple dots over here, gradient would be negative, but they would be different negative values. Right. So the gradient changes on a curve depending where on the curve I am. Right. What differentiation does is it allows us to work out what the gradient is at a particular point, and this is how it does it. Okay, so let's first talk about traditional methods, and then we'll talk about why we use the formula that we do. Okay, let's pretend that I want to join together 2 points on a function. So let me just clear what I've got here, and we'll draw a nicer graph that I haven't walked. or have it written all over. Okay. So we must draw ourselves a new set of axes. There we go. There's a new set of axes for us. All right, so there's our X, there's our Y. And again, I'm going to draw something that looks a bit rounded, but I'm doing this on purpose. Okay, so let's say, ooh, it looks like this. Sorry, it's so difficult to draw a parabola over there. Okay, so let's pretend that this is the graph of y equals f of x equals x squared. Okay, if I want to work out gradient using gradient formula, I could say that this point over here is point A, and I could say that that point over there is point B, all right? I can use my traditional gradient formula to calculate the average gradient from A to B. Do you remember hearing the words average gradient in grade 11? Do you remember hearing that? Anybody remember hearing the words average gradient? Okay, cool. That's good. So when we are calculating the average gradient, okay, so what I'm going to do is just manipulate this a little bit. Just change the thingy of our line. There we go. All right, so if I am calculating the average gradient from A to B, all right, it basically means that I have connected A and B with a straight line and I'm working out the gradient of that line. That's what average gradient means. But that doesn't tell me what the gradient is at A, and it also doesn't tell me what the gradient is at B. It just gives me an average. Okay, so I want to know what the gradient is at A specifically. So using traditional methods, let's just use stuff that we already know. Let's pretend, okay, that at A, x is equal to 4. If 4 goes in, what would y be equal to? It would be equal to 16. Okay, so that means that 16 would be my output. Let's say that over here, 12 goes in. All right, what would my output be? That's it, Tando. Okay, 144. So if I want to work out the average gradient of line AB, I would say, so this would be 144. I would say my change in y, so 144 minus 16 over my change in x. So that would be 12 minus 4. And I might end up with a fraction here because after all, I'm just making up numbers. So if I get 144 and I take away 16, then I'm going to end up with a numerator of 128. And 12 minus 4 would leave me with 8. And if I divide 128 with 8, I end up with 16. Okay, so that's my gradient, 16. So that tells me how steep the line is. Can you see it would be a positive gradient? Okay, because I'm walking uphill. As I walk from A to B, I'm walking uphill, so I'm expecting this to be a positive number. Okay. Now, this is where the problem comes in, right? Let's pretend that I don't want to calculate the gradient between A and B. I only want to calculate the gradient at A. Okay. If I use my traditional gradient formula, I end up with a problem. Okay. That's because I've only got one point. So at A, I've only got the coordinates 4 and 16. So if I sub into gradient formula, I end up with my change of y being 16 over 16. And at the bottom, I end up with 4 minus 4. Now, the 16 minus 16 at the top is not the problem because I can have a numerator of 0. The problem is here at the bottom, okay? If I have 4 minus 4 at the bottom, it means I've got 0 in my denominator. Okay, so if anything is divided by 0, then it becomes undefined. So in other words, using traditional methods, if I want to work out the gradient of the function at A, it's going to be undefined. Okay, and that would happen for any particular point if you used traditional methods. In other words, if we're using our gradient formula. So a long time ago, some very, very clever people discovered something different. Okay, and this is what they found when they did it by first principles. That's what we're talking about today. They said, let's take the same question, but let's think about it in a different way. All right. So now instead of working with numbers, they said, let's get rid of the numbers. Okay. And let's do this instead. Let's say that at A, the x coordinate is called x, and the y coordinate that comes out is called f of x or y. Well, that's something that we've all seen before. We know that we can write our x coordinate as x and our y coordinate as f of x. So we know that that can be any point. If I am now talking about this point over here, it is to the right of x. So in other words, if I've got x, I have now moved to the right of that. So let's say I decide to go h places to the right-hand side. H just represents a number of units to the right that I'm moving. I would now say that the coordinate at this point over here is now x plus h, because I started at x and I moved h places to the right. That means that my corresponding y coordinate at B is going to be f of x plus h. Okay. Now they did this. They said, we want to work with gradient. We want gradient at a particular point at A. So if I sub into gradient formula, I would have the y at B minus the y at A over the x at B minus the x at A. Instead of calling gradient M, they discovered a new way or created a new way of writing gradient. So gradient can also be written as f prime A. Means exactly the same thing. It's just different notation. So what I'm going to do is I'm going to replace this with some new notation. I'm going to call it f prime x equals. Now something's going to go here, right? But I'm just going to write it. So instead of the y at B, instead of the y at B, I'm going to call the y at B f of x plus h. My y at A is f of x. In the denominator, my x coordinate is x plus h minus my x coordinate over here is x. We're going to simplify that a little bit. I just want to talk about what happens over here. Here we write the word lim, which stands for the word limit. Okay, now limits, strictly speaking, are not part of our CAPS syllabus. All right, so we're not going to be asked to calculate limits when we are doing this section. The first question is always going to be on first principle. But basically what this is talking about when we say our limit is h tends to 0, now this has a very specific meaning, okay, and it has to stay in our question all the way to the end, and I'm going to explain when it goes away. This is what it means. What we are doing, what we are pretending is happening here is that this point at B is moving. If I want to work out the gradient at A, B is moving back down the curve towards A, right? As B gets closer and closer to A, the distance between the 2 points gets smaller and smaller and smaller. So imagine if you get into your car or into a bus or into a taxi or onto a horse, it doesn't matter, and you are traveling from one point to another. Let's say you are going from your home to school. As the car, the bus, the taxi, whatever it is, moves down the road towards the school, what happens? The distance between you and the school gets smaller and smaller and smaller until eventually when you get to school, all right, you have now got to your destination. So in other words, the distance between where you were and where you are now is now 0. Okay, because you've arrived at your destination. Okay, that's what it means when we say h tends to 0. Okay, so this distance between these 2 points gets so small that eventually this second point B is now on top of A. All right, that's what we say when we say h tends to 0. What we're going to do is we are going to sub into this formula in order to calculate the gradient at a particular point. First of all, we just need to simplify it. So in the denominator here, we end up with in the numerator, f of x plus h minus f of x. Those are not like terms, but at the bottom over here, x plus h minus x means that h is left over. So this is your formula for first principles. Okay, and that is where it comes from. No one is going to expect you to explain what I've just told you. But rather than starting a lesson or having a lesson where you don't understand what f prime x is, you don't understand that it's gradient and it comes from gradient formula, you can now work with meaning if you understand where it comes from. Okay, the rest of it is just substitution and algebra. Okay, are there any questions before we move on and go and look at an example? Is there anything that you want to ask me? Any questions, Matrix? Which x? Oh, well, I took the x away, okay, because it's my change in x. So it's x plus h minus x. So these are like terms. Okay, so x, this x over here minus this x over here means that those two would add up to 0. X minus x is 0. So that's why only h is left behind. Yes, m is the gradient. Okay, so Nolutando, what's happening here is h is tending to 0. What it means is that the distance between B and A is getting smaller. Okay, until B is on top of A, and then there is there's the distance between them is now 0. Okay, so that's what we mean when we say h tends to 0. Okay, the distance between the 2 points has now become 0. So it's like you being at home and then you arriving at school. As you are in the car on your way to school, the distance between you and the school is getting smaller and smaller. Okay. So Danelle, your starting point is where I've drawn the green block. Okay, that's where you'll start. This is the formula that you'll sub into, and you'll see that on your formula sheet. Okay, so this is going to be your starting point. Okay, the one with the green block around it. Okay, Any other questions before I move on and I show you how to use this formula? No, we all good? You sure? Cool. All right. Lovely. Okay, everybody. I'm glad you're feeling good about that. Okay, so let's do this example first. All right. So they've asked us to find or determine from first principles. Here's our first principles formula. The gradient of f of x equals 1 minus 3x squared at any point. Okay, so this is what we would do. Oh, where's my pen gone? Oh, there it is. Okay, this is how I like to set it out. Okay, let's just move that out the way. Move this up here. Okay, write down what f of x is. So on the side, you're going to write down f of x in this particular question is 1 minus 3x squared. Then write down what f of x plus h is. So what this means is that you are replacing the x with x plus h. So we would end up with 1 minus 3, and in place of our x, we would write x plus h, and then we would square it. So this means that we would end up with our binomial here. That would be x squared plus 2xh plus h squared. And then when we remove our brackets, we would end up with 1 minus 3x squared minus 6xh minus 3h squared. Now we are going to sub into this formula. Okay, so subbing into the formula, we need to write the following. F prime x equals your limit as h tends to 0, f of x plus h is 1 minus 3x squared minus 6xh minus 3h squared. Now, what you can do, because you are subtracting f of x is a binomial. So when you subtract, your signs need to change. So it's going to become minus 1 plus 3x squared. And then you must write over h. Your h can't disappear out of the question and then reappear back in there later on. Okay. In your second line, you're going to keep your limit notation. So your limit is h tends to 0. And what you will find is that every term that doesn't have an h in it must add up to 0. So the only terms with h's in them are going to be left in the next line. Can you see we're going to have 1 minus 1? So the 1 becomes a 0. And we also have minus 3x squared plus 3x squared. So we only left with h's over here. So this gives us minus 6xh minus 3h squared all over h. Now, this is where factorization comes to the rescue. All right, and it helps us to get rid of this denominator or not write that the denominator is 0 by factorizing. So we take h out as a highest common factor. Minus 6x minus 3h, like so, all over h. Then h divided by h gives us 1. So we've got around our denominator not being 0. And we're almost there, equals our limit as h tends to 0, and we've got minus 6x minus 3h. Now, you are not allowed to show that h is 0, okay? Because if you show h is 0, then it means that we could show that h was 0 here, or here, or there. Now, we cannot have division by 0. So you may not show that h is 0. You've got to do it in your head. Okay, remember, we're bending the rules, we're not breaking them. So when we are ready, after we have factorized, when we are ready to sub in that 0 in our heads, all we do is we say to ourselves, okay, this last term over here, if I subbed in h was 0, all right, then that term would become 0. So my final answer, I'm dropping my limit notation now, would just be negative 6x. Okay, and that is how you would set it out. Incidentally, you would get a mark for subbing in and then changing your signs correctly. There would be an accuracy mark on simplifying, a mark for factorizing, and a mark for your final answer. Do not show that h is 0. Okay, all right, now questions. Let's have a look. Is f of x given? Always, Raphael. I hope I pronounced your name correctly. Okay, it's always, always, always given. Okay, so they'll always say to you, find from first principles f prime x if f of x equals, and then they'll give you the question. Okay, are there any questions? Any other questions? Non-demiso?
Ma'am,
Mm.
so when you get to the end of the sum
Mm-hmm.
and you're left with a binomial, so should you always just like drop the last number there?
So you are going to drop. So what will happen is that any term that has an h in it will become 0.
Oh, okay, okay.
Okay, so you may have constants as well, which would be part of your answer. But any term that has an h in it would not be shown in your final answer.
Okay. Okay.
Okay,
Thank you, ma'am.
all right, no problem. Okay, so the reason that you stopped writing limits is because you are now at that point where you would have subbed in that h was equal to 0. Okay, but you're not allowed to do that. You're not allowed to write that h is equal to 0. So when we get to that point where we're now ready to sub in the 0, we do it in our heads, and then we're allowed to drop the notation h tends to 0. Okay, so it's only when we get to that point where we were going to sub in the 0 that we can drop our limit notation. Okay, so it's always the very sort of, it's always going to be your sort of second to last line if you're doing it like this. Whenever you're ready to sub in h in your head, h is 0 in your head, that's when you're going to drop the limit notation, is just after that. Okay. All right, so I'm going to show you another question that's a little bit more difficult, right? Because this is the sort of more challenging lesson. And then I'm going to give you a question to try. Okay, so let's look at this one. I'm just going to make it a little bit bigger and scooch over to the side here. Let's just go over there. All right, now imagine if they told us to do a question like this. Okay, determine from first principles the derivative of f of x equals 1 over x. Okay, so again, if f of x equals 1 over x, then it means that f of x plus h is 1 over x plus h. Subbing into first principles, this is what we would end up with. We would get f prime x equals our limit as h tends to 0 of f of x plus h. So f of x plus h over here is 1 over x plus h minus 1 over x all over h. Nizole, it can be applied to any function statement. Okay, so most often parabolas, but yeah, any function statement. How do we subtract fractions, Matrix? How do we subtract fractions? What do we need if we want to subtract fractions? Exactly, we need a lowest common denominator. So now inside all of this formula, okay, we're going to have to work with the lowest common denominator. So we're not allowed to drop our limit notation yet. And now we're going to find an LCD. Our LCD is going to be x times x plus h. That's our lowest common denominator. So in our numerator, we're going to have x minus x plus h. Okay, so our lowest common denominator, we've multiplied the two together. All right, and that's why at the top we've now got x minus x plus h, and then all of this needs to be over h. So this divide line that was there is now here. I hope everybody's happy with that. Then in our next step, we've got our limit as h tends to 0. X minus x plus h means that at the top, we've now got negative h all over x times x plus h all over h. Okay, next step. So we've got to keep our limit notation. And now what I'm going to do is I'm going to write this out in another format for you guys. So we've got minus h over x times x plus h. And then what I'm going to do here is that means divided by h. Okay. When we divide fractions, what's the rule? What's the rule when we divide fractions? We have to tip in times. Quite right, Shisana. Okay, so this is going to become our limit as h tends to 0. We're going to keep the first fraction the same. And here, we're going to tip in times. Now remember, that's h over 1. So this is going to become 1 over h. Okay, now we are allowed to cancel something at the top with something at the bottom. Okay, so now we end up with this. Our limit as h tends to 0. So now when we're working with fractions, we multiply numerators and we multiply denominators. So negative 1 times 1 would give us negative 1. And at the bottom, we've got x times x plus h. Exactly, we're going to change it to a multiplication. Quite right. So once we have done this, okay, we are now at that point where we have factorized out our h. We've gotten rid of it over here. Well, instead of factorizing, what we've done is we've multiplied by the reciprocal so that we can get rid of that h at the bottom. All right. Now, remember, we are not allowed to show that that has become 0. Okay. So in our next step, okay, in our heads, we are writing that that is 0 in our heads, not on paper. Okay. If it became 0, then what I would have is minus 1 over x squared, like so. Does that make sense to everybody? Okay, because this term over here would become 0. Okay, and either you could leave your answer like that, but it would probably be more likely that you would write it as minus 1 over x squared like this. Okay, and that would be your final answer. So there's no need to do that. Okay, there's no need for you to do that. Nolatundo, how you got minus h from the second one? Sure. So it comes from making so you've made your denominator, you've got your LCD, and then what you've done here is you've done the same thing to what you do to the denominator, you've got to do to the numerator. So in other words, what you've done is you've said I have to times this by x, so I must times this by x. That's why you've got that x there. And then here I've got to times this by x plus h, so I must times that by x plus h. Okay, and then when your brackets go away up at the top here, you're going to end up with x minus h. So that becomes 0, and that's why you've only got that minus h left over there. Okay. Why would it be wrong for it to be in fraction form? You see, you've started off with something that's a fraction. So if you think about it, if you were doing the power rule and they gave you f of x equals 1 over x, then what you'd have to do here is you'd have to write that as 1x to the power of -1. Okay, and then if you did your power rule, you'd end up with f prime x equals -1 times 1 would be -1, and then that would be take 1 away. Right, so it would be the same thing. Okay, you'd end up with -1 at the top and x squared down at the bottom. Okay, so using your power rule, you can see you've got the right answer. No, so you're not. You're allowed to leave your exponents with negative exponents. I mean, here in first principles, it's going to end up being a positive exponent. But when you're doing your power rule, you don't have to write things with positive exponents. So it's a bit of a weird thing. I don't know why CAPS does this. But in grade 9, 10, and 11, you have to write everything with positive exponents, and then when you do calculus symmetric, you can leave your answers with negative exponents. Okay, if you haven't done the power rule at school, you wouldn't understand what I was doing on the side here, but it's just a way for you to be able to check that your answer is correct. Okay, all right, so what I'm going to do now is I'm going to give you guys an opportunity to, so Bonga, when you've got h divided by h, it becomes 1. Okay, this h over here becomes 0. So it's going to be x times x, which gives you your x squared at the bottom. Okay, all right. Let's go and have a look at a question for you to try. And if there's anybody else that wants to ask me something, then you can try. Okay, so let's give you this question to do. Okay, so this comes out of a past paper. This is it's not that much more difficult, but you've got 2 x's. Okay, so let's see how you guys go with this particular question. And I'll just grab the first principles formula for you. Where is it? It's over there. Okay. There it is. Okay, so screenshots, just do that quickly, everyone. Okay, so screenshots, please. Screenshots, screenshots, screenshots. Remember, you can always watch the video again. Just fast forward to the point that you want. Okay, and there's our final answer. Okay, so what you are left with all right, is an expression that allows you to calculate the gradient at a particular point on a function. Okay, if you know what the x coordinate at that point is, you can work out the gradient of that particular line.
Hello, ma'am.
Yes, so hello.
Can I ask, is there a way of calculating all of this with the calculator? Like putting...
No, no,
Okay.
no, unfortunately not. Unfortunately not. Okay. All right. So there we go. We're going to practice this question. We haven't got much time left, Matrix. So let's give this question a try.
We can do this, Matrix. We can. We can really, really do this. We are nearly there. Oh, Kanyiso is like done. Wow, that was fast. Ish, Teacher Lee, these people are so fast.
They
Tando's
are, aren't
also
they?
done. Yeah. Whoa. Okay, guys.
Oh, wow. You guys are amazing. Yeah, see, once you get it, it's actually very, very easy. And it's not meant to be difficult. It's meant to be easy, easy marks. If you want a challenge, if you really want a challenge, okay, what you can do, this is just on the side here. This is a different question. Not everybody has to do it. But if you really want a challenge, what you can do is determine from first principles this. Okay, so I don't know if there's any of you that are feeling, we won't be able to discuss it this lesson, but maybe we can discuss it next lesson if you want to try that. If you don't understand that, don't stress. This is the sort of normal question. You can see this was taken out of an exam paper. Okay, so who's feeling brave and wants to tell us how they did this? Can anybody feeling up for that? Bridget, go for it.
Hello, ma'am.
Hi,
Can you hear
Bridget.
me?
Yes, I can hear you well.
Okay, thank you. So I took the f of x plus and the formula, and I dropped down my f of x plus h is equals to x plus h squared plus x. And then I dropped that down and I wrote x squared plus xh. Wait, sorry, ma'am. X squared plus 2xh plus x h squared in brackets plus x.
Lovely, good.
And then I
Keep
put
going.
down f of then on the left side I wrote f x h x plus h.
When you say on the left,
on the left side, then it's a way my sir taught me before we do the LUM formula.
yes. So if you've got f of x is equals to x squared plus x, then you've got f of x plus h. So now you can go straight to subbing in here.
Okay, no problem, ma'am.
Okay.
So f prime of x lum x h2 equals to 0.
Yes.
Is equals to 2xh plus h squared over h.
Oh, okay. So now what you've done is, I see what you've done here is, I get it. So what you're telling me Okay, sorry, Bridget, I misunderstood you, but I get you now. What your teacher's done at school is your teacher's taught you to do this. That's what you mean, isn't it?
Yes, ma'am.
Okay, so it's just another way of setting it out. That's fine. So, and then you've got minus x squared minus x like
And then,
so. Okay, and
and
that's where
I
you ended up with 2xh plus h squared. I understand. So lovely. Okay, so then you've got f prime x equals your limit as h tends to 0. And then here, sorry, Bridget, you had 2xh plus h squared over h, right?
yes, ma'am.
Lovely.
And
Carry
then
on.
I go down and I go f prime to x lim formula h tends to 0 and
Mm-hmm.
equal to h brackets x plus h over h.
Okay.
And then I go down again, lim formula lim
Mm-hmm.
h to 0 x plus h.
Lovely. Keep going.
And then we drop the lim formula and we end up
Mm-hmm.
with x only. Thank you, ma'am.
Okay, so well done. Okay, so you ended up with 2x as your answer.
Yes, ma'am.
Okay, I just want to double check that I haven't made any mistakes here.
Hello, ma'am.
Aren't we supposed to end up with 2x plus 1 as our answer?
Yes, ma'am. That's what I wanted to.
Yes. Yes.
X to
Okay. Okay, so just hang on. Let's just find our mistake here. So we've got x squared plus 2xh plus h squared.
I found my phone.
That's,
It was
sorry.
2.
You know
2 I
where I
forgot.
realized where the mistake was here we needed to have x plus h, didn't we?
Yeah.
Okay. Sorry, Matrix. All right, let's just fix that up. Okay, so that means that we end up with x squared plus, that's why it's never a good idea for me to write too quickly, plus x plus h minus x squared minus x. Okay. Which then means that we're going to end up with x squared. No, sorry, our x squared will go away because it's going to end up with 0. And we're going to end up with, beg your pardon, 2xh plus h squared plus h. Sorry, and that's what's supposed to go into the numerator over here. Don't stress. Okay. Okay. So we're going to end
Just
up
don't
here.
leave for the poll. Sorry. Don't leave for the poll, guys. Let's stay a little bit.
Okay. I'm nearly there. And then those would cancel and we would end up with 2x plus h plus 1. And then when we drop our limit notation, we would end up with that. There we go. We fixed it. Okay. So that's what we should have had here. Okay. Was this? It was just because, sorry, I was rushing. And then in place of this x, I didn't write x plus h. Okay, but we've fixed it now. It's all perfect. Where does the h come from? Which h are you talking about, Bonga? Well, if you take h out as the highest common factor, then h times 1 gives you h, doesn't it?
Bonga, you can also raise your hand like this. It will be faster. Ah, okay. Bonga understands now.
Okay, all right. Do you want to do the poll?
Oh, yes, please.
Go for it.
Guys, well done. Y'all did amazingly well. I love calculus, my people. So We'll get it. We'll get it. We'll get it right. So please, let's just vote before we go. So my background is very noisy, so I'm just gonna mute myself.
Hello, ma'am.
Hello, Tsegofatso. How are you?
I'm good, and how are you, ma'am?
I'm fine, thank you.
Can I ask how would they mark this question?
Yes, very good question. I'm glad you asked me that. Okay, so there is always a mark for subbing in. Okay, so in other words, what you would get is a mark for calculating f of x plus h. You would get a mark for calculating the difference between the two. So either they would give you the mark, they would give you the mark over there for subtracting. Then there would be an accuracy for that one for simplifying. There's always a mark for taking out h as the highest common factor, and then they would give you a mark for the answer. So most of the time, these questions are out of 5. They do penalize you if you drop your limit notation too soon, or if you don't set it out in the correct way. Okay, but there you go.
So, ma'am, what is setting it too soon? The limit.
So in other words, like let's say I don't have my limit notation over here. They're going to penalize me. Sometimes
Okay.
students write the limit notation on the wrong side. So in other words, you end up with something like this, f prime x, and then you get the limit notation over here, and then you get the equal sign. So if you do things like that, then they penalize you. So if you're not sure, go back to your formula sheet and just look and make sure that your formula is correct. Okay.
Okay.
Also where they penalize you is if your h magically disappears at the beginning. So in other words, it's not written over here, and then it finds its way back into the question later on. So the idea is don't squash it all together. Make sure that there are clear lines so that you can see what's in the numerator and what's in the denominator. Okay. And that's going to
Okay.
help a lot.
Okay. Thank you, ma'am.
Okay, no problem. Kamal, do you want to ask a question?
Yes, good evening, ma'am.
Good
I
evening.
I wanted to ask, I got like confused when it was time to substitute f of x into the derivative formula
Okay.
right here at the
So,
top.
all right.
Because
So,
because you can carry on, it's okay.
sorry. So, what Bridget did, all right, is her teacher at school has just shown her how to sub in the numerator, right? It's it's exactly the same thing. So, instead of us writing a whole long line here, she's taken this bit over here and she's just worked it out what it's going to be. And then she's taken the answer and she's gone and subbed it in there. All right. It would be absolutely the same thing as if we set it out like this. So if we had f prime x equals, come on, pen, equals our, silly thing, equals our limit as h tends to 0. Now, this is f of x plus h over here. So now you've got x squared plus 2xh plus h squared plus x plus h minus f of x. Now, f of x, of course, was x squared plus x. So minus x squared minus x all over h. She's just done this on the side and then gone and subbed in the simplification. It means exactly the same thing. Okay, I didn't understand what she was saying at first. And then once she explained it to me, I got it. It's exactly the same thing. Now you're going to end up with exactly what we had in this line, which is 2xh plus h squared plus h all over h. And then you would proceed with the rest of the question. Okay, it's exactly the
Okay,
same thing.
thank you.
Okay, pleasure, no problem.